So Argentinosaurus is arguably the biggest animal that's ever walked on the planet. It's 40 meters long and it weighs 80 tons. So this animal is at least 10 times bigger than the largest elephant ever. So like a lot of dinosaurs, we don't have a complete skeleton of Argentinosaurus. We have most of its legs and some of its backbone. So the first thing I wanted to know was this realistic? Could you actually have an 80-ton animal that worked? First of all, we have to get all the information we can from the fossil. So we laser scan the skeleton, and so we can get a digital model of the whole animal. Then, of course, we have to put on the soft tissue, because it's things like muscles and tendons that actually power the animal. So then we actually create what I call a virtual robot. So it's a simulation in the computer of the skeleton and the muscles. And so it can move exactly the way we would predict the animal can. And then the really difficult bit is actually getting it to walk. So we use what we call machine learning techniques. So what we don't want to do is we don't want to tell the animal how it moves. So we're not animators. What we want to do is the animal needs to learn how to move the best way it can using the muscles and skeleton we've given it. When we did the reconstruction, we found out that the only way we could make this animal work was by allowing certain compromises. If we allowed the animal to be very flexible, to move its limbs through very large angles, then there was no way it was strong enough. It could not support its own weight. It was only by restricting the ranges of movement for the limbs that it was actually strong enough to support itself. This means that this animal was right at the limit of what you would expect. So this is a simulation showing the best solution that the big computer came up with. So it can simulate this in real time, and you can see the individual muscles firing off because they change color to show when they're active. So we have an efficient walking pattern that's custom built for this particular dinosaur. So this is going at about 5 miles per hour, and it's a reasonably efficient gait. And actually, if we compare where the feet go down on the ground, they actually match trackways that we find for these animals. So this is a really good simulation.